Hi, this is a single breadboard computer designed by somebody called cOpperdragon, and I wanted to show you because I think it's fascinating that he could make a whole computer with just 4 chips. So it consists of quad NAND gates, a 6502, 32K of RAM, and 32K of ROM. It's running at 10 megahertz. That's the reset button, and this is the serial interface, so that goes to USB port to terminal emulator. And the reason why it hasn't got a serial chip like a 6551 or a 6850 is that it uses interrupts to receive data, and it bit bangs the output, so it's all software controlled, and it's really cheap, really easy to build. I built it in one go, about an hour or something, following the design. It worked first time. I've added to the ROM, I've added version of WSmon for it, and also ported Microsoft Basic, and I'll show you that in a minute. Right, this is the terminal emulator that is connected to a single breadboard computer. And the setup for the terminal I've got is receive line feed and transmit control and line feed, because I didn't really change my version of WSmon. So this seems to work quite well. I'll press the reset button, and as you can see, we've got WSmon prompt there. So we can, it's WSmon, it's running at 10 megahertz, so it's quite speedy. So that's quite nice. But if we can now go into basic, so I think it's this address here, and just memory size, terminal width, let's do that. And we now need to pick up some basic. So I've got, let's see, Mandelbrot. Let's try the Mandelbrot first. And we'll just paste that in. Unfortunately, the computer can't accept a very high rate, so I had to put in the terminal, I had to put in a delay, and it makes it very slow. So this is how long it takes to load up. So about speed of a loading off a tape, I think. So it's not very good. I can list that. So yep, it's all gone in, and if we run it, we should see Mandelbrot, and it takes about 18 seconds. This is real time, it's not sped up or anything. So this is same speed I'm seeing it. It's using characters instead of colors, of course. Nearly at the end. If you work that out, it's around 18, 19 seconds. So that's pretty comparable to, say, the Commander X16. Just runs at 8 megahertz, so it's slightly faster than that. But you know, I've just proven that basic seems to work, and it could do a Mandelbrot. And the only other thing I've got at the moment is a game of life, so we need to do new here, paste it in. I just got this off the website somewhere. It's supposed to be written for the BBC and Commodore 64. I've just changed it so it clears the screen each time. If we run it at, and let's go for 16 by 16 and the probability of 0.3 for the initial one. And there you go, Gen 1, Gen 2, you know, and it's there and it's running. Just game of life's not very big. We try running it basic on our Commodore 64 is going to go a lot slower than this. So the fact that it's running at 10 megahertz just shows, you know, it's quite useful even running basic mounts, and it's dead already. So let's press Control C and let's run it again, maybe a bit bigger. Let's go maximum actually. And 0.03. As you can see, it takes a bit longer to do each generation. Written in assembly, it'll be much faster than this, of course. And it took me a little while to get the Control C to work because the way the interrupts are working. So at first, it wouldn't recognize Control C, and I had to put a little delay in. So that seems to work now. That's basically all I've got to show. Thanks for watching. And we shall break there. Bye.